Hello everyone, this is Kalpana here. In this video, we're going to solve a differential equation. So let's get going. Problem: solve y times 20x square plus 8xy plus 4y square plus 3y cube into dx plus x square plus xy plus y square plus y cube into 4x dy equal to 0. So this is of mdx plus ndy equal to 0 form, right? Which is of mdx plus ndy equal to 0 form for m equal to y times 20x square plus 8xy plus 4y square plus 3y cube, and for n equal to x square plus xy plus y square plus y cube into 4x, right? So we can write this m as 20x square y plus 8xy square plus 4y cube plus 3y power 4, and we can write this as 4x square into x cube plus 4x into x square y plus 4xy square plus 4xy cube, right? If the partial derivative of m with respect to y equal to partial derivative of n with respect to x, then we can say that the given differential equation is an exact equation. So now let's find the partial derivative of m with respect to y and partial derivative of n with respect to x. If it is not equal, then the given equation is not exact. Okay, fine. Now coming to the partial derivatives. Partial derivative of m with respect to y equal to, for m equal to 20x square y plus 8xy square plus 4y cube plus 3y power 4. Here we are partially differentiating terms with respect to y, so we'll treat x as constant. So in the first term 20x square is constant, in the second term 8x is constant, in the third term 4 is constant, and in the last term 3 is constant, right? Now we'll write this as 20x square into partial derivative of y with respect to y plus constant into partial derivative of y square with respect to y plus constant into partial derivative of y cube with respect to y plus constant into partial derivative of y power 4 with respect to y, right? This gives us 20x square into partial derivative of y with respect to y is 1 plus 8x into partial derivative of y square with respect to y is 2y plus 4 into partial derivative of y cube with respect to y is 3y square plus 3 into partial derivative of y power 4 with respect to y is 4y cube, right? This gives us 1 into 20x square plus 8 2s are 16 xy, 4 3s are 12 y square, 3 4s are 12 y cube. Okay, so this is the partial derivative with respect to y. Now coming to partial derivative of n with respect to x. Partial derivative of n with respect to x. We have n 4x cube plus 4x square y plus 4xy square plus 4xy cube, right? Here we need to partially differentiate n with respect to x, so we'll treat y as constant. In the first term 4 is constant, in the second term 4y is constant, in the third term 4y square is constant, in the last term 4y cube is constant. So we can write this as constant into partial derivative of x cube with respect to x plus constant 4y into partial derivative of x square with respect to x plus constant 4y square into partial derivative of x with respect to x plus constant into partial derivative of x with respect to x. This gives us 4 into partial derivative of x cube with respect to x is 3x square plus 4y into partial derivative of x square with respect to x is 2x plus 4y square into partial derivative of x with respect to x is 1 plus 4y cube into partial derivative of x with respect to x is 1. Right? This gives us 4 3s are 12. 12x square plus 4 2s are 8xy plus 4y square into 1 4y square plus 4y cube into 1 4y cube. By observing these two, we can say that the partial derivative of m with respect to y is not equal to partial derivative of n with respect to x, right? Therefore, the given differential equation is not exact. Consider the given differential equation as equation 1. This shows that 1 is not exact. See, here we have shown that equation 1 is not exact. Okay, now since it is not exact, so we need an integrating factor to make the non-exact equation to an exact equation. We'll reduce this to an exact equation. Let's see that. Now coming to the problem, we are given a differential equation which is non-exact, right? Given differential equation, y times 20x square plus 8xy plus 4y square plus 3y square, sorry, it's cube, right, into dx plus x square plus xy plus y square plus y cube into 4x dy equal to 0. We have considered it as equation 1, right? We know that if the given differential equation can be written of the form x power a into y power b into mydx plus nx dy plus x power c into y power d into pydx plus qxdy equal to 0, then x power alpha y power beta will be the integrating factor, right? Or instead of alpha and beta you can take hk, okay? Or if the given differential equation is of the form, say m into x power a y power b plus p into x power c y power d into y dx plus n into x power a y power b plus q into x power c y power d into x dy equal to 0, then x power alpha y power beta will be the integrating factor, or x power h y power k. Instead of alpha and beta we can just take h and k, okay? If the given equation can be written of any of these two forms, then x power alpha y power beta will be the integrating factor. But in our case we have an equation of 1 2 3 4 4 terms, 1 2 3 4 4 terms. See inside, each term is of x power something into y power something form. See, you can write this x square as x square into y power 0 form, right? Likewise you have xy, that is x power 1 y power 1, which is of x power into y power form. And here you are having y square can be written as x power 0 into y square form, right? Y square can be written as x power 0 into y square, which is of x power into y power form. And likewise 3y cube, here you are having y cube, 3 is a constant, right? You have constant, and this y cube can be written as x power 0 into y cube. Since x power 0 is 1, y power 0 is 1, right? So you can write each term as some constant into x power 0 into x power some number into y power some number form, right? Likewise in this term, in this term we have x square. So we can write this x square as x square y power 0, that is x power into y power form. Likewise, you are having x y, which is of x power 1 into y power 1, x power y power form. And you can write this y square as again x power 0 into y square, which is of this form. Likewise, the last term y cube can be written as x power 0 into y cube, which is of again x power into y power form, right? So we are given a differential equation which is of this form, right? Here you are having two terms, but in our case we are having four terms in each term, right? So here x power alpha y power beta will be our integrating factor. Okay, we can write the given equation as 20x square plus 8xy plus 4y square plus 3y cube into y dx plus x square plus xy plus y square plus y cube into, you need to multiply all the terms with this 4, so you'll get 4x square plus 4xy plus 4y square plus 4y cube into x dy equal to 0, which is of this form, right? But you have four terms. Here you're having two terms in the formula, and here you're having four terms. Okay, now since the given differential equation is of this form, so here let x power alpha y power beta be the integrating factor. Right? So what we'll do? Now we'll just multiply this integrating factor to the given differential equation so that the given differential equation is reduced to an exact equation. So let's see that. Multiplying one by integrating factor x power alpha y power beta. Okay, we have equation 1, y into 20x square plus 8xy plus 4y square plus 3y cube into dx plus x square plus xy plus y square plus y cube into 4x dy equal to 0. Now we can write this as x power alpha y power beta into 20x square y plus 8xy square plus 4y cube plus 3y power 4 into dx. See, we have multiplied all these four terms with this y. Okay, now here we need to multiply all these terms with this 4x. Then we'll get 4x into x square gives 4x cube plus 4x into xy gives 4x square y plus 4x into y square 4xy square plus y cube into 4x gives 4x y cube into dy equal to 0. Now we can write this equation as x power alpha y power beta into the first term 20x square y plus 8xy square plus 4y cube plus 3y power 4 into dx plus x power alpha y power beta into 4x cube plus 4x square y plus 4xy square plus 4xy cube into dy equal to 0. Now we can write this as 20 x power alpha into x square y power beta into y plus 8 x power alpha into x y power beta into y square plus 4 x power alpha y power beta into y cube plus 3 x power alpha y power beta into y power 4 into dx plus 4x power alpha x cube y power beta plus 4x power alpha x square y power beta into y plus 4x power alpha into x y power beta into y square plus 4x power alpha into x y power beta into y cube into dy equal to 0, right? This gives us 20. Here the bases are equal, so we can add the powers. You'll get x power alpha plus 2, y here also just add the powers. You'll get y power beta plus 1 plus 8 into x power alpha plus 1, y power beta plus 2 plus 4 x power alpha y power beta plus 3 plus 3 x power alpha y power beta plus 4 into dx plus 4 x power alpha plus 3 y power beta plus 4 x power alpha plus 2 y power beta plus 1 plus 4 x power alpha plus 1 y power beta plus 2 plus 4 x power alpha plus 1 y power beta plus 3 into dy equal to 0. Consider as equation number 2. Say equation 2 is exact if partial derivative, see this is of mdx plus ndy equal to 0 form, right? For m equal to 20x power alpha plus 2 y power beta plus 1 plus 8x power alpha plus 1 y power beta plus 2 plus 4x power alpha y power beta plus 3 plus 3x power alpha y power beta plus 4, and for n equal to 4x power alpha plus 3 y power beta plus 4x power alpha plus 2 y power beta plus 1 plus 4x power alpha plus 1 y power beta plus 2 plus 4x power alpha plus 1 y power beta plus 3, right? So if partial derivative of m with respect to y equal to partial derivative of n with respect to x, I mean equation 2 is exact if the partial derivative of m with respect to y equal to partial derivative of n with respect to x. So now we need to find, okay, now we can write this as partial derivative of m for m equal to 20 x power alpha plus 2 y power beta plus 1 plus 8 x power alpha plus 1 y power beta plus 2 plus 4 x power alpha y power beta plus 3 plus 3 x power alpha y power beta plus 4 equal to partial derivative of n with respect to x, 4 x power alpha plus 3 y power beta plus 4 x power alpha plus 2 y power beta plus 1 plus 4 x power alpha plus 1 y power beta plus 3, sorry it's 2 y power beta plus 2 plus 4 x power alpha plus 1 y power beta plus 3. Okay. So in LHS part we need to partially differentiate the terms with respect to y. So we'll treat x as constant. In the first term 2x power alpha plus 2 is constant. In the second term 8x power alpha plus 1 is constant. In the third term 4x power alpha is constant. In the last term 3x power alpha is constant, right? Likewise in RHS we need to partially differentiate all the terms with respect to x. So we'll treat y as constant. In the first term 4y power beta is constant. In the second term 4y power beta plus 1 is constant. In the third term 4 beta y power beta plus 2 is constant. In the last term 4 y power beta plus 3 is constant, right? So now we can write this as constant into partial derivative of y power beta plus 1 with respect to y plus constant 8x power alpha plus 1 into partial derivative of y power beta plus 2 plus constant 4x power alpha into partial derivative of y power beta plus 3 plus 3x power alpha into partial derivative of y power beta plus 4 with respect to y equal to constant 4y power beta into partial derivative of x power alpha plus 3 with respect to x plus 4y power beta plus 3 into partial derivative of x power alpha plus 2 plus 4y power beta plus 2 into partial derivative of x power alpha plus 1 with respect to x plus constant 4y power beta plus 3 into partial derivative of x power alpha plus 1 with respect to x. This gives us 20x power alpha plus 2 into partial derivative of y power beta plus 1 with respect to y is beta plus 1 into y power beta plus 1 minus 1 plus 8x power alpha plus 1 into partial derivative of y power beta plus 2 with respect to y is beta plus 2 into y power beta plus 2 minus 1 plus 4x power alpha into partial derivative of y power beta plus 3 with respect to y is beta plus 3 into y power beta plus 3 minus 1 plus 3x power alpha into partial derivative of y power beta plus 4 with respect to y is beta plus 4 into y power beta plus 4 minus 1 equal to 4y power beta into partial derivative of x power alpha plus 3 with respect to x is alpha plus 3 into x power alpha plus 3 minus 1 plus 4y power beta plus 1 into partial derivative of x power alpha plus 2 with respect to x is alpha plus 2 into x power alpha plus 2 minus 1 plus 4y power beta plus 2 into partial derivative of x power alpha plus 1 with respect to x is alpha plus 1 into x power alpha plus 1 minus 1 plus 4y power beta plus 3 into partial derivative of x power alpha plus 1 with respect to x is alpha plus 1 into x power alpha plus 1 minus 1. This gives us 20 x power alpha plus 2 into 1 gets cancelled and you'll get beta plus 1 into y power beta plus 8 x power alpha plus 1 into beta plus 2 into y power beta plus 2 minus 1 gives plus 1 plus 4x power alpha into beta plus 3 into y power beta plus 3 minus 1 gives plus 2 plus 3x power alpha into beta plus 4 into y power beta plus 4 minus 1 gives plus 3 equal to 4 y power beta into alpha plus 3 into x power alpha plus 3 minus 1 plus 2 plus 4 y power beta plus 1 into alpha plus 2 into x power alpha plus 2 minus 1 gives plus 1, right? Plus 4 y power beta plus 2 into alpha plus 1 into x power alpha plus 4 y power beta plus 3 into alpha plus 1 into x power alpha. This gives us 20 beta plus 1 into x power alpha plus 2 y power beta plus 8 beta plus 2 into x power alpha plus 1 y power beta plus 1 plus 4 into beta plus 3 into x power alpha y power beta plus 2 plus 3 beta plus 4 into x power alpha y power beta plus 3 equal to 4 into x alpha plus 3 into x power alpha plus 2 y power beta plus 4x alpha, it's alpha, okay. 4 alpha plus 2 into x power alpha plus 1 y power beta plus 1 plus 4 alpha plus 1 into x power alpha y power beta plus 2 plus 4 alpha plus 1 into x power alpha y power beta plus 3. Now, by equating the equations of x power alpha plus 1 y power beta, you'll get one equation, and by equating the quotient of x power alpha plus 1 y power beta plus 1, you'll get one equation, and by equating the quotient of x power alpha y power beta plus 2, you'll get one equation, and by equating the quotients of x power alpha plus 1 y power beta plus 3, you'll get x power alpha y power beta plus 3, you'll get one equation. Okay, by solving any of these two equations, you'll get the values of alpha and beta. So let's see that. Now I'm just equating the equations of x power alpha plus 2 y power beta, which gives 20 times beta plus 1 equal to 4 times alpha plus 3, which gives us 20 by 4 into beta plus 1 equal to alpha plus 3, which gives 5 beta plus 5 equal to alpha plus 3, or we can write this as alpha plus 3 equal to 5 beta plus 5, which gives us alpha. Now just take this 5 beta to LHS and 3 to RHS. We'll just get alpha minus 5 beta equal to 5 minus 3, which gives us alpha minus 5 beta equal to 2. Consider as equation A. Okay. Now let's equate the equations of x power alpha plus 1 y power beta plus 1. Equating the equations of x power alpha plus 1 y power beta plus 1, which gives us 8 beta plus 2, 8 times beta plus 2 equal to 4 times alpha plus 1. It's 2, right? Alpha plus 2, which gives us 8 by 4 into beta plus 2 equal to alpha plus 2, which gives 2 into beta, 2 beta plus 2 2s are 4 equal to alpha plus 2, or we can write this as alpha plus 2 equal to 2 beta plus 4. Now bring this 2 beta to LHS, take this 2 to RHS, which gives us alpha minus 2 beta equal to 4 minus 2. From this we'll get alpha minus 2 beta equal to 2. Consider as equation number B. Now equating the equations of x power alpha y power beta plus 2, which gives us 4 times beta plus 3 equal to 4 times alpha plus 1. From this we'll get beta plus 3 equal to alpha plus 1, right? Now we can write this as alpha plus 1 equal to beta plus 3. Bring this beta to LHS, take this 1 to RHS, we'll get alpha minus beta equal to 3 minus 1. We'll get alpha minus beta equal to 2. Consider as equation sum C. Now equating the equations of x power alpha y power beta plus 3, which gives 3 times beta plus 4 equal to 4 times alpha plus 1. You can write this as 3 beta plus 3 4s are 12 equal to 4 alpha plus 4 1s are 4, or 4 alpha plus 4 equal to 3 beta plus 12. Now bring this 3 beta to LHS, take this 4 to RHS, you'll get 4 alpha minus 3 beta equal to 12 minus 4. From this you'll get 4 alpha minus 3 beta equal to 12 minus 4, 8. Consider as equation D. Now solve any of these two equations. Okay, just pick any two equations from these four and solve them to find alpha and beta. So I'll take the first two. Okay, solving A and B, we get alpha minus 5 beta equal to 2, alpha minus 2 beta equal to 2, plus alpha minus alpha gets cancelled, plus 2 minus 2 gets cancelled, minus 5 beta plus 2 beta gives minus 3 beta equal to 0. From this you'll get beta equal to 0. Now put beta value in any of these two equations. Let's take equation A. We have equation A, alpha minus 5 beta equal to 2. We can write this as alpha equal to 2 plus 5 beta. Since beta equal to 0, then you'll get alpha equal to 2 plus 5 into 0, which gives us 2. Therefore alpha equal to 2. Therefore alpha equal to 2, beta equal to 0. Now we got the values of alpha and beta. Let's now find the integrating factor. So you can pick any two equations. If you consider C and D, right, this is equation C and this is equation D. So we need to multiply 4 to equation C. You'll get 4 alpha minus 4 alpha gets cancelled, plus 8 minus 8 gets cancelled, minus 4 beta plus 3 beta gives minus beta equal to 0. From this we'll get beta equal to 0, right? Now just put beta equal to 0 in any of these two equations. Let's substitute in C. We have equation C, alpha minus beta equal to 2. I'll write this as alpha equal to 2 plus beta. Since beta equal to 0, so you'll get alpha equal to 2. Okay, fine. Likewise, you can take any of the two equations. Pick any two equations from these four. Okay, you can just take any two equations from these four equations. Either you can take A, B or B, D or C, D, anything. Now integrating factor becomes x power alpha, y power beta will be equal to x power, just substitute the values of alpha and beta here. You'll get x square, y power 0 is 1. Here x square is the integrating factor. Since y power 0 equal to 1, you'll get 1 here, okay? Therefore, x square is the integrating factor to our problem. Now, by multiplying this x square, that is integrating factor, to the given equation, the given equation is reduced to an exact equation. Let's see that. Multiplying equation 1 by the integrating factor x square, you'll get x square into y times 20x square plus 8xy plus 4y square plus 3y cube into dx plus x square plus xy plus y square into y cube plus y square plus y cube plus 4 into 4x dy equal to 0, which gives us x square into 20x square y plus 8xy square plus 4y square into y cube plus 3y square, y cube into y power 4 into dx plus x square into 4x cube plus xy into 4x square y plus 4x into y square 4xy square plus 4x into y cube 4xy cube into dy equal to 0. Now multiply all the terms with x square. We'll get 20x square into x square. Just add the power since the bases are equal. So you'll get x power 4 into y plus 8x square into x cube into y square plus 4x square y cube plus 3x square y power 4 into dx plus 4x square into x cube. Add the power, so you'll get x power 5 plus 4 x power 4y plus 4 x cube y square plus 4 x cube y cube into dy equal to 0. Okay. Now consider this equation as equation number 3, which is of mdx plus ndy equal to 0 form, right? Mdx plus ndy equal to 0 form for m equal to 20x power 4y plus 8x cube y square plus 4x square y cube plus 3x square y power 4, and for n equal to 4x power 5 plus 4x power 4y plus 4x cube y square plus 4x cube y cube. Okay, if the partial derivative of m with respect to y equal to partial derivative of n with respect to x, then we can say that the reduced equation 3 is an exact equation. So let's now find the partial derivatives of m and n, m with respect to y and n with respect to x. I'll begin with the partial derivative of m with respect to y here. For m equal to 20x power 4y plus 8x cube y square plus 4x square y cube plus 3x square y power 4. Since we need to partially differentiate all the terms with respect to y, so x is treated as constant. In the first term 20x power 4 is constant, in the second term 8x cube is constant, in the third term 4x square is constant, in the last term 3x square is constant. So we can write this as 20x power 4 into partial derivative of y with respect to y plus 8x cube into partial derivative of y square with respect to y plus 4x square into partial derivative of y cube with respect to y plus 3x square into partial derivative of y power 4 with respect to y, which gives us 20x power 4 into partial derivative of y with respect to y is 1 plus 8x cube into partial derivative of y square with respect to y is 2y plus 4x square into partial derivative of y cube with respect to y is 3y square plus 3x square into partial derivative of y power 4 with respect to y is 4y cube, right? Which gives us 20x power 4 plus 8 to the 16 x cube y plus 4 to the 12 x square y square plus 3 4 is 12 x square y cube. Now we got the value of partial derivative of m with respect to y. Now we are going to find the partial derivative of n with respect to x. Partial derivative of n with respect to x. For n equal to 4 x power 5 plus 4 x power 4y plus 4x cube y square plus 4 x cube y cube. Here we need to partially differentiate all the terms with respect to x. So here y is treated as constant. In the first term 4 is constant, in the second term 4y is constant, in the third term 4y square is constant, in the last term 4y cube is constant. Now we can write this as constant into partial derivative of x power 5 with respect to x plus constant into partial derivative of x power 4 with respect to x plus constant into partial derivative of x cube with respect to x plus constant into partial derivative of x cube. It's x cube, right? X cube with respect to x. Which gives us 4 into partial derivative of x power 5 with respect to x is 5 x power 4 plus 4y into partial derivative of x power 4 with respect to x is 4 x cube plus 4y square into partial derivative of x cube with respect to x is 3x square plus 4y cube into partial derivative of x cube with respect to x is 3x square, right? Which gives us 4 5s are 20 x power 4 plus 4 4s are 16 x cube y, it's cube, okay, plus 4 3s are 12 x square y square plus 4 3s are 12 x square y cube. Okay, now by observing these two, we can say that partial derivative of m with respect to y equal to partial derivative of n with respect to x. So this shows that the reduced equation, equation 3, is an exact equation. Therefore, partial derivative of m with respect to y equal to 20x power 4 plus 16x cube y plus 12x square y square plus 12x square y cube equal to partial derivative of n with respect to x, that is, which is nothing but partial derivative of m with respect to y equal to partial derivative of n with respect to x, which shows that equation 3 is exact. So we have reduced the given differential equation to an exact equation. Now we'll find the general solution to the given equation by finding the general solution to the reduced equation. Since the reduced equation is an exact equation, so we'll use the general solution formula of an exact equation to find the general solution to our problem, right? You know that the general solution to an exact equation is given by integral mdx treating y as constant plus integral terms of n free from x into dy equal to c. Okay, now we'll find each integral, separately for m and n, and finally let's find the general solution to our problem. Integral mdx treating y as constant equal to integral for m equal to 20x power 4y plus 8x cube y square plus 4x square y cube plus 3x square y power 4 into dx. Here we'll treat y as constant, treating y as constant. So in the first term 20y is constant, in the second term 8y square is constant, in the third term 4y cube is constant, in the last term 3y power 4 is constant. Now we'll write this as 20y integral x power 4 dx plus 8y square integral x cube dx plus 4y cube integral x square dx plus 3y power 4 integral x square dx, which gives us 20y into integral x square dx is x power 5 by 5 plus 8y square into integral x cube dx is x power 4 by 4 plus 4y cube into integral x square dx, x cube by 3 plus 3y power 4 into integral x square dx, x cube by 3, which gives us 4x power 5 y plus 2x power 4 y square plus 4 by 3 x cube y cube plus x cube y power 4. Okay, so the result obtained from the first integral is 4x power 5y plus 2x power 4 y square plus 4 by 3 x cube y cube plus x cube y power 4. Right, now coming to the second integral. Integral terms of n free from x into dy, which gives, now observe n, we don't have term in n which is free from x, right? We don't have terms of n which are free from x. So what we'll do, since there is no such term which is free from x, so integral of terms of n free from x is 0. So the result obtained from the second integral is 0. Therefore, the general solution is given by integral mdx, treating y as constant, plus integral terms of n free from x into dy equal to c. The result obtained from the first integral is 4x power 5y plus 2x power 4y square plus 4 by 3 x cube y square plus x cube y power 4 plus result obtained from the second integral 0 equal to c, which gives us 4x power 5y plus 2x power 4y square plus 4 by 3 x cube y square plus x cube y power 4. It is cube, okay, not square, sorry. See, we have cube here, equal to c. Now take y common from all these terms. So this is a required general solution, or we can write this as, just take y common, you'll get 4x power 5 plus 2x power 4y plus 4 by 3 x cube y square plus x cube y cube into y equal to c. Now take this c to RHS, you'll get 4x power 5 plus 2x power 4 into y plus 4 by 3 x cube y square plus x cube y cube into 1 by y into c. We can write 1 by y as y inverse, right? So I'll get c into y inverse. Therefore, 4x power 5y plus 2x power 4y square plus 4 by 3 x cube y cube plus x cube y power 4 equal to c, or 4x power 5 plus 2x power 4y plus 4 by 3 x cube y square plus x cube y cube equal to c into y inverse is the required solution. Well, we have seen a problem from differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.